Hi everyone, in this video we will look at the chi-square goodness of fit test. The goodness of fit test is used when you want to check if things are happening as predicted or as forecasted, which means that the null hypothesis is that the data fit the expected pattern, and the alternative hypothesis is that the data does not fit the expected pattern. You could use this test in various scenarios, in say quality control, artifacts happening at the expected rate, null hypothesis yes, alternative hypothesis no. In market research, are customers responding to product demos as predicted? Null hypothesis yes, alternative hypothesis no, they aren't. The bottom line is that the chi-square goodness of fit test tells you whether your expectations match reality. If they don't, you reject the null hypothesis. In this example, we have a retail store that's trying to check that if their monthly sales pattern follow the historical patterns. So what's the null hypothesis here? It is that the monthly sales pattern follow the same seasonal patterns as the historic 3-year average, and the alternative of course is that it doesn't. To check whether this is true, let's use SigmaXL's statistical tool. So let's go to SigmaXL, statistical tools, go all the way down to chi-square test. And once we click here, a new template is going to open. So let's click on this. So this is the new template that's opened. Go back to your original file, copy all this data. So all the 12 months data, the observed versus the expected sales. Copy it and paste it here as in values and number formats. The moment we paste this, SigmaXL is going to generate a result, right? Let's paste that. So you can see that SigmaXL has generated a few numbers here. Let's look at what's been generated here. The first important thing to note is the chi-square value itself, and this number looks huge. And what we are going to do is we are going to compare it with the chi-square table under 11 degrees of freedom. Why 11? Because there are 12 months in a year, n-1, and that takes us to 11. And the significance level for most business scenarios is 95%. So that's what this represents. And the number here is 26.757. Our calculated value is about 21,146, which is way bigger than the significance level and the critical value. So we can reject the null hypothesis. We can also do that by looking at the p-value, which is a 0.0, which means that it's less than 0.05. Now, if you want to explore the mechanics of this test a little bit more, you can click here to see to show and hide the calculations. And you can specifically look at this column here, the one that says contribution to chi-square number. The bigger the number here, the larger is the variation from expected. So for example, in the month of May, the observed sales were about 125,000. The expected were only 2,000 more. So this number is smaller. But if you look at the months of January, February, or even December, the variations were huge. How is this number calculated? It's calculated by doing observed minus expected whole square divided by the expected value. Now going back here to hide the calculations again and focusing simply on our chi-square statistic and p-value. So on the basis of this p-value and on the basis of this chi-square square statistic, we can reject the null hypothesis. And what was it? It was that the sales pattern is following this historical average. It's not. The retail stores management, based on this, the retail stores management needs to investigate what's causing this change, and they need to update their seasonal forecasting models. Hope you found this video useful, and thank you for watching.